So we're switching gears just a little bit today to do systems of linear inequalities. How is this going to be different than previous lessons? They were equal in the other ones. So on the quiz, whenever I graphed those two lines and I asked for the solution, how did I know where the solution was? It's on the line, on either of the lines. Where the two lines meet was one solution. Now we have an inequality. Anytime we've had an inequality this semester, we've had a range of answers. We've had, for instance, we wrote it in interval notation from 5 to infinity. Same idea today. We're going to have a range of answers. So whenever I'm looking to solve a system of linear inequalities, what I'm looking for is the set of all xy points. There might just be a couple xy points. There might be several xy points. There could be no xy points that will satisfy each inequality that is in the system. I'll probably give you some systems that have 2, some systems have 3. If I get real mean, I'll give you a system that has 4 inequalities in it. Depends on how well you guys treat me over these next few days. Okay. Yes. So you will want to graph, you will want to shade. Sure. I draw with a pencil and shade with a color. All right, so I'm just going to make these up as we go through. If you want to help, feel free to. I'm going to start off pretty basic to make sure everyone's on the same page with this. So I'm going to do y is greater than or equal to, let's say, -2, and x is less than 6. I meant to do those in 2 different colors. So the first order of business is going to be get these lines drawn. Okay, according to your syllabus, what CMO sent me, it said it has to be a linear inequality. So a lot of my books that I have, in even my Algebra 2 book, everything's with parabolas and absolute value, square root functions. But I'm just going to go by what the syllabus says. It says linear inequality. So everything we'll be graphing will be a straight line. So first order of business is going to be draw these straight lines. Let's just ignore the inequality for now. Let's just suppose it said y equals -2. What does that look like? So go to -2 and draw a horizontal line on the y. Okay, I got that. I got off a little bit. So what will the difference be whenever I change it to x equals 6? A vertical line, yeah. 1, 2, 3, 4, 5, 6. So I'm going to purposely go ahead and mess up. Not meaning to draw a double line. For some reason it's picking up 2 today. All right. So where did I mess up? Huh? I haven't shaded yet, but I've messed up just graphing these 2 lines. Oh, dotted and solid. How do I know if it's dotted or solid? Good. Okay. So the one that's strictly less than this 6 right here is supposed to be a dotted line. There's a dotted line going down. Jaden asks why. That's a great question. Can you ask that in about 5 minutes at the end of this problem? Okay. I think we might get through it in 5 minutes. Before I erase this, before I draw the big circle around everything, Jaden, I hit erase. Say, hey, why? All right, I'll tell you. That's a great question of mine because you probably weren't told why. Now, if I'm going to teach this properly, here's what I'm supposed to tell you next. I'll show you the Mr. Lovelady way in just a minute. But if I'm going to teach this properly, what I'm going to do is I'm going to say, okay, now what you're going to do is you're going to get a test point that is not on the line. Anything that's not on this blue line. So I choose the nicest point that is not on that blue line. I love plugging in 0. So I choose the point 0, 0. And I'm just plugging in this first one right here. So I'm going to take this y value, and I get 0 is greater than or equal to -2. Is that true? It is true. So what I want to do is I want to shade where 0, 0 is according to this line. So 0, 0 is above the line. So I'm going to shade all of this up here above the line. All right, so let's do this again. Unfortunately, I got another one that worked. So 0, Ilba. If I plug in 0 in for this one, again, I'm only interested in the x on this one. We'll have x and y in the same one in just a minute. If I plug in 0, I get 0 is less than 6. Is that true? It is true. So what I want to do is I want to shade where 0, 0 is, according to this red line right here. So that would be everything over here on this side. Oh, wow. So is the whole thing shaded? Well, this isn't shaded. What is my answer? The part where it overlaps is going to be my answer. Okay? Because look at what I've done. Oops, sorry. I've shaded above the line. I've shaded to the left of the line. I'm wanting x, y points that satisfy both inequalities. So the only ones that do that is where I double shaded. So go back. If you did shade both, just go back and color this part in up here just a little bit darker for me so that I know what to grade. It's okay if this is shaded. So maybe shade real light, and then the part that overlaps, shade that darker. Or use different colors. Or I'll show you what I normally do whenever I work a problem like this in just a minute, because I can't stand all this shading and scribbling, and that does look pretty good though. You can do this. Just make sure I know what your final answer is. It's shaded a little bit darker than everything else. Yeah, that's what I'm going to do in just a minute. Okay. All right, Jaden wants to know why this line is solid and this one's dotted. It's because this solid line right here is part of my shading. It's okay if I choose points that are on this line right here. Okay, it's part of my shading because it is greater than or equal to -2. Whenever it's a dotted line like this, this represents that this boundary right here is not part of my shading. I'm not allowed to put points on this line because it has to be strictly less than 6. It is. Dotted, solid. If it has the or equal to. Yeah. I'll do that each time just so you get used to it. All right, any other questions? Yeah, your answer is that shaded region. It's all those x, y points that are in both of those regions. Do what? Yeah, I mean, that's going to be the question. The answer is all of these x, y values that are in this double shaded region. Do what? I could. I'm thinking about it on the quiz. It'd be multiple choice if it was. All right, let's make one up because that always works well. Y is greater than or equal to -1/3 x plus 4. And let's come down here and do 3y plus x is less than -1. Okay, we're mixing x's and y's on both of these. Okay, so looking at this blue line up here, what's my y-intercept? 4. 1, 2, 3, 4. And which way do I go from there? Which way over? Left. Okay, so I can go up 1 over 3 to the left, or down 1 over 3 to the right. Either way, it's a negative slope, so my negative slope has to be going up to the left. So we don't have to do that much erasing. Am I doing a solid or a dotted line on this? Solid. I will come back and talk about the shading on this one in just a minute. I like to get my lines on there first. Okay, what about this next one down here, the red? Ah, you don't like the form it's in? What form do we want it in? Y equals mx plus b, okay? If you know how to graph using intercepts, this isn't very hard to graph using intercepts. There's not much work to do, but I've had a lot of people go today to the y equals mx plus b. So 3y x minus 1. So divide everything by 3, and I get negative 1/3 x minus 1/3. So using my same rules on this, I'm just going to come down to right here. It's the same slope. So negative 1. Solid or dotted? You're dotted on this one, okay? Not very straight. Now I'm ready to go back and talk about where to shade this at. So I'm going to go to the blue line. Now, what I can do is I still can plug in 0 and 0. And this time I'm going to plug in 0 in for x. I'm going to plug in the second 0 in for y and see if it gives me a true statement. And if it's true, I shade where 0, 0 is. However, third hour didn't take very kindly to it, but fourth hour, they liked my DHS easy button. Are you ready for the DHS easy button? There's a benefit in saying and getting this down to y equals mx plus b, or y is greater than mx plus b, okay? Y greater than this line right here just means that I'm interested in all the y values that are greater than, or if we're talking about y values above this line. So whenever I'm looking at this blue line right here, I'm wanting to shade everything that is above it. And instead of shading and getting all the different colors mixed up on there, I just put little arrows to show which side of that line I'm shading. I can kind of visualize that. So looking at this red line down here, and again, if I was to plug in 0, I would get 0 is greater than 4. Is 0 greater than 4? No, it's not. So I'm shading where 0, 0 is not up here. So I'm still using that same rules with my test point. However, the DHS easy button, if it solves for y, you can just use that. So y is less than this red line. Which side do I shade if y is less than? Shade the bottom. So if I'm shading all of this up here, and I'm shading all of this down here, what's my answer? No solution. Why? I shaded. They have to overlap. I'm looking for points that are shaded both blue and red, where they overlap and satisfy both equations. Nothing here satisfies. So don't leave your answer like this, because I'm going to assume that you mean this split region right here to be your answer. Answer is no solution. Good. Everybody okay? I keep doing the pointers. Let's do one more. We'll split this one up. All right, so guys, I'm going to let you take 3x minus 5y is greater than 7. Ladies, you got negative 2x plus 4y is less than or equal to 1. Negative 1. I'll throw a negative 1 in there. And then anybody that's bald with big teeth that's wearing a black jacket today, you get x is greater than negative 5. All right, so go ahead and work that out. And if you're watching this video, go ahead and hit pause and then come back and see if you match the graphs that we put up here. Okay, so our lines are right here. Yeah, we should get the shade on this. The red line, am I above or below? It's the class pet, just leave it alone. Are we above or below? We're below. So let's look at the 3 regions that these have in common. If I was to shade all this, if you want to shade all this, go for it. Where am I shading at? Okay, I need to, so I don't need to shade in between the red and the blue? No, I just want down here. Make sure you get close to that boundary so that I know where you're talking about. Okay. Just below the bottom one, because I don't want to go above the blue line because it doesn't satisfy staying below the blue line. Okay. Good. Here's the link to your homework.